Hello everyone. In this video, we are going to look at map reduction. By map reduction, we mean the process of reducing or decreasing the size of a given map. So let's go and look at the main way. For successful reduction of a map, the following tools are very important. You need a pencil. With a pencil, you are able to demarcate the beginning and the ends of measurements of your map, the length and breadth of your map. Then we need erasers. So as you reduce or enlarge a map, when one makes mistakes along the line, the erasers are very important to clear the mistakes for a restart. Then we also need a long rule, a very important tool in map enlargement and reduction. You need to measure the length and breadth of your map, and the rule is very important in this particular exercise. Now, when using a long rule, if your rule do not have 0, begin with where centimeter is. So you measure from there to wherever the measurement of your map ends. Now, this is a sample map that we'll be using for the exercise. On the map, there is a scale, and on the map, there are border lines. So please take note of the scales and the border lines that we'll be using. Now, you can see the scale of the map, and the scale of the map here is 1 centimeter to 2 kilometers. 1 centimeter is 2 kilometers, which means that the 1 centimeter measured on the map represents 2 kilometers on the ground. Now we look at a trial question. The question says, reduce the map extract provided on the scale 1:200,000 to half of its original size. How do we do this? Now, in the case of this nature, the half in this particular question is very important. You take note of the half in this question. So the half here mathematically represents 1/2. So that particular half is something you should note, because the half becomes our scale factor. So we have to take note of it. So wherever I refer to a scale factor, we are referring to this 1/2. So having looked at the map, please, we do not measure the map. When measuring the length and breadth of your map, we do not measure it from the outer border lines. These outer border lines are not part of your measurement area, so please take note of it. However, this is the ends of the map, and we need to measure from these areas. So please take note, these are the areas we need to measure. This is your breadth, and you can measure here, which is your length. So from here to this place is your length. So when you finish measuring it, then we can proceed. You take note of the scale as well. So these are the ends you need to measure your map. Now, we have finished the measurement of the map. What do we do next? We note down our measurements. So the length of the original map that is given to us is 20 centimeters. As you can see here, the length of the original map is 20 centimeters. Then the breadth of the map is 10 centimeters. So we have to find the new breadth and new length for our new map. So how do we find that? Our new length is equal to original length times a scale factor. And our scale factor, I already said from the beginning that it is 1/2. So that is what we have here. So that is our scale factor. So having seen our scale factor, we need to look at our new scale. So what then is our new scale? So we already said in the formula here that our new scale is equal to original length times scale factor. So our original length is 20 centimeters times the scale factor, which is 1/2. So mathematically, every whole number is over 1, and that is why here we have 20/1 times the scale factor, which is 1/2. So this gives us 20 times 1 gives us 20, then 1 times 2 gives us 2. And dividing 20 by 2, it gives us 10 centimeters, which is our new length. So we look at our new breadth or width. Some prefer calling it width, others prefer calling it length. So we look at our new breadth. So our new breadth is 10 centimeters. So we multiply it by our scale factor, which is 1/2. So as I said earlier, every whole number is over 1. So we have here 10/1 times the scale factor, which is 1/2. So multiplying 10 by 1, it gives us 10. And multiplying 1 by 2, it gives us 2. So dividing 10 by 2, it gives us 5 centimeters. So these 5 centimeters become our new breadth. So having measured and having calculated our new length and our new breadth, we draw our new map area. So here we have our new map area. This is the breadth of the map and this is the length of the map. So here we have 10 centimeters, which is the length, the new length, and 5 centimeters, which is our new breadth. So please do remember, anytime you draw your new map, remember to put the new length and the new breadth at its appropriate places, and don't forget to draw your cardinal points indicating the directions of your map. So you see my cardinal point here, and it has the north, the west, the east, and the south. So we have we have to get a heading for our reduced map. So we have a reduced map of Mulai Southwest. Then don't forget to put your new scale. So my new scale is down here. Now, how do we get a new scale? It's very important. I already said, looking at the original map has a scale 1 centimeter on the map, representing 2 kilometers on the ground. So we take notice of it very well. Now we have to calculate our new scale. For the new scale here, we have the formula original scale times the scale factor. So what is our original scale then? So by a representative fraction, the original scale, which is 1 centimeter to 2 kilometers, will be 1 is to 200,000, which can also be expressed mathematically as 1/200,000. Now, we said our scale factor is 1/2. So therefore, our new scale will be 1/200,000 times the scale factor, 1/2. So what does it give us? 1 times 1 will give us 1. Then 200,000 times 2 will give us 400,000. This means our new scale becomes